What just happened? Let's see if we can use physics to find out. Set up an experiment to learn about the effects of momentum. We'll use a smooth, level table, checked with a level, in a draft-free space. The main internal force in our system will be an impulse or push from a person who is part of our system. The possible external forces affecting our system are gravity, friction, and drag. We designed our system to minimize these effects. The object we will use to test our system is an empty Chinese noodle can. We chose it after testing and rejecting several other cylindrical objects. We marked the center of the lid with a dot. There is a very small 1 millimeter difference between the diameter of the lid and the diameter of the base of the can. We think this won't affect our results. We're wrong, as you soon will see. We take the video you saw in the opening shot and put it into Tracker, an open source application we downloaded from the internet. We choose which frames we want Tracker to analyze and mark them. We want to start after the push or impulse so the object will not be accelerating, but will be moving at a steady rate. We enter the size of the can lid as a calibration for the video. Using the dot we made in the center of the lid, we mark the position of the center of gravity of the can in each frame. Then, Tracker analyzes the motion and generates a graph and a table of values, showing the object's position on the X and Y axes. Now we have the data we need to do an analysis in VIDLE running VPython. Now we will open another open source application, VIDLE, and open a template created in the open source language VPython. We will modify the template using information from our measurements and data the Tracker has generated. We will enter such things as the mass of our object, the final frame we analyzed, and the initial conditions when Tracker began the analysis. When we finish editing, we will move our VPython code into a Google Docs spreadsheet to generate graphs and data for a model based on our experimental conditions. We open our Google Drive and import our VPython code to the spreadsheet program. Google Docs will analyze our data and generate data for a virtual model of our experiment based on the information we entered and the laws of physics based on Newton's second law of the momentum principle. To generate our graph, we will need to copy and paste the model times from column A to column C under the experimental times. And the model positions from column B to column E, taking care to match up the correct times and their matching positions. Now we're ready to generate a graph. There seems to be something wrong with our recording. All we have is the graph for the experiment. What happened to the graph for the model? Well, it turns out that in copying the model data down in columns C and E, I accidentally did them in C and D. Had to change them, and when I changed them, they didn't match up right. So I had to go a different route. I used a screen grab of the experimental graph on Google Docs and transferred it to a presentation program on my Mac. Then I used the data for the model from Google Docs, and using 2 points they gave for the model, I added a line representing it on my graph. I sized the image so that 25 centimeters on the graph was 25 millimeters on my screen. I used a ruler to do this. Old technology, I know, but it still works. Now I have a graph showing both the experimental and model positions. And what a difference! What went wrong? Well, it looks like that 1 millimeter difference in size between the can lid and the can bottom was far more important than I thought it would be. It was like a cart or a car with one bad wheel. If I were to do this again, I would probably use a full jar of peanut butter, where the lid does not touch the surface and it just rolls along on a smooth, symmetrical side. I think its larger mass would also help. Influence on this system probably were mostly gravity acting on the out-of-balance can and some friction between the can and the table surface. This was a good way to take a look at Newton's second law that says if an impulse acts on an object, it will move in the direction it is pushed until other forces act on it, like gravity acting on my wobbly out-of-balance can.